Hey guys, this is the final part of 4.2. I'm on page 351. Okay, so now what we're going to do is just remind ourselves about intercepts. We've talked about this before. We're coming back to this, and we're just going to do a real quick review of how to actually find these. So for x-intercepts, so what you want to do is you want to set the y part of an equation equal to 0, and then you solve for x. And then for y-intercepts, you set the x part of the equation equal to 0, and then you solve for y. So I want to do that on these two, or on this example here. So I just want to do a quick review of kind of how to do that, because this will help us out later in this section. So starting with x-intercepts. So once again, just in case, x-intercepts, you set the y part equal to 0, and then solve for x. So it's nice and straightforward. So maybe you want to pause the video and do that yourself. Hit play when you're ready. Okay, so I'm going to set the y part equal to 0. So y part equal to 0, and then solve for x. So this becomes 2x equals 12. Divide each side by 2, I get x equals 6. Okay, now there's a second part of this. X-intercepts are always of the form a comma 0. So this is kind of the last part of this. So you want to make sure that you actually state this as a point. So this is the point 6, 0. So this is one x-intercept. These are two separate points. So now let's go and find the y-intercept. So we basically do the opposite thing. We set the x equal to 0 and solve for y. So again, maybe you want to pause here, solve, hit play when you're ready. So let's see, now I get negative y equals 12. Divide each side by negative 3, and I get y equals negative 4. And so now, if I write out what this point would be, this would be the point 0, negative 4. So you want to make sure when you talk about intercepts that you actually write down what the intercept is. And they are two separate points, right? It would be incorrect to say that the intercept is 6, negative 4. That is not the case. They are two separate points. So that's a big distinction. Okay, so that's something we wanted to have reviewed before we start this. And so maybe just to go one step farther with this now, I want you to do one of these examples on your own. So actually we'll do two of these. Why don't you go ahead and find the x and y intercepts of, let's do 2x minus 5y equals negative 10. And then let's also do y equals 3x minus 2. Pause the video here and just find the x and y intercepts of each of these equations. Hit play when you're ready. Okay, so starting here, so let's see, I'll maybe divide this into parts. Okay, so let's start by finding my x-intercepts. So I need to set my y equal to 0, so this becomes 2x minus 5, not 50, 5 times 0. So that's got to equal negative 10. So if I work this out, this becomes 2x equals negative 10. If I divide each side by 2, I get x equals negative 5. So this will be the point negative 5, 0. Okay, and now let's do the y-intercept. So now I'm just going to do the opposite, right? So I'll have 2 times 0 minus 5y equals negative 10. So this means then that negative 5y equals negative 10. And if I divide both sides by negative 5, I'm running out of space here, excuse me. So this will be y equals 2. So now I've got the point 0, 2. So there would be my x and y intercept for the first one. So now let's do it for the second one. Okay, so now slightly different looking equation, but this will kind of lead us, a good segue for the next part. So this is leading us where I need us to go. So I'm going to set my y equal to 0. So let's see, I'll go ahead and call this my x-intercept. Set my y equal to 0. So I get 3x minus 2. And now I've got to actually solve for x. Now in this case, this is slightly more tricky, right? Because I've got to actually go through a little more work. So I'll go ahead and I'll just add 2 to each side. So I get 2 equals 3x. Divide each side by 3. And I get x equals 2/3. So it's a little more work to figure that out, but same ideas. It's 2/3 comma 0. And now check out what happens with the y-intercept here. So if I just plug in 0 for x, now this side's actually much simpler, right? Because there's nothing I have to solve for. Actually, everything just falls out and I'm just left with negative 2. And so this would be the y-intercept 0, negative 2. And so this brings up, notice that this is in y-intercept form. And also notice, so -2 was the y-intercept. So we already talked about that as part of the definition of the slope-intercept form. But now what I want to do is actually kind of understand this just a little bit more deeply. So from this form of the equation, we actually get quite a bit of information, and it makes graphing a lot easier, and it just makes working with the whole process just a lot more straightforward. So I really want to get used to looking at these types of equations. So what I want to do with this table here is I'm going to give you an equation. I want you to tell me what is the slope. Now remember, my slope is going to be in my m, and then my y-intercept is going to be my b. And all of your equations are in this form y equals mx plus b. So the thing attached to the x is my m, and the freestanding number is my b. And I want to put the y-intercept, whatever my b is, I want to put it in y-intercept form. So I actually want to put it in this form 0, comma b. So let me show you what I mean. So starting here with this first one, so notice what's attached to the x. The 3 is attached to the x, so that's my slope. So my m is equal to 3. So there's my m. The freestanding number is this 2. So I want to write this out as the y-intercept 0, comma 2. So that's what I want you to do. So if I do one more of these with you, so looking at b, so -2/5 x plus 1, so what's my slope? My slope is -2/5, and then my freestanding number would be this 1, so as an intercept, this would be 0, 1. So why don't you try the next 3, hit play when you're ready. Okay, so for the next one, so this is kind of an invisible slope, but this would be the invisible slope of -1, and then my y-intercept will be 0, 3. Now, for the next one, I just have y equals x. So remember, whatever number is attached to x is the slope. It's not a 0 for a slope, it's that invisible 1, that's my slope. And then this is really y equals x plus 0. So we can omit the 0, right? If you're adding 0, you just omit it. So the y-intercept in this case is just 0, 0. Therefore, for e, my slope would be just 2, and once again, my y-intercept would be 0, 0. Okay, so now what I want to do is I want to talk to you guys about actually graphing equations in this slope-intercept form. So we've already seen if you have a point and you have a slope, it's pretty straightforward to graph these things. And now I have a bunch of equations that are in the slope-intercept form. So what I want to do is first I want to identify the slope. So like in this equation here, what would my slope be? Well, my slope in this case, my m is 2, and then my y-intercept would be 0, -1. So what I'm going to do then is I'm going to come up to the y-axis, so right here, and I'm going to count where -1 is. So here's where 0, 0 is. So if I come down 1, there's my y-intercept. So your y-intercept, this is actually even better than some of the exercises we were doing earlier, because your y-intercept will just always be on this line. So it's almost like you don't have to go searching all over the graph for it. So there's my y-intercept. Now I need to count out my slope. Now remember, this 2 actually stands for 2 over 1. So I need to go up 2, up 1, 2, and then over 1. And there would be my line in this case. So if we do one more of those together, so in b here, so notice the number attached to my x is this -1/3, so that's going to be my slope, that's -1/3. Oops, not -1/2, -1/3. And then, oh, and I'm losing the page, -1/3. And then my y-intercept is going to be this point 0, 2. So first I come to the y-axis up to 2. So here's my y-axis. I'm starting here at 0. I come up 1, 2. So I'm going to mark this point here. And then I have to count out the slope. So now this is negative. So that means starting from here, I'm going to go down first, down, and then to the right, because it's always, always right. So I go down 1, and then to the right, 1, 2, 3. And so now I'm good to go. Okay, so maybe you want to pause the video here and give C a try. Hit play when you're ready. So we already talked about this one. So here we already said my slope was 1, and we talked about that my y-intercept was 0, 0. So I'm actually just going to start here at the origin, and then I'm going to go, oops, I'm going to go up 1 over 1, up 1 over 1. I'm going to just draw 3 points just to make me a little more sure of myself. And so that's kind of the idea behind this. So I have now on this next page just slightly trickier examples. So I want you to pause the video and give all 3 of them a try. Hit play when you're ready. So notice for A that this just says y equals 3. This does not say 3x, right? So in this y equals mx plus b form, what must that say then about the x? That would mean that we have 0x. 0x plus 3 is actually the way that we could think of this. So maybe I'll write that here. I can think of this as y equals 0x plus 3. And looking at this then tells me that I must have a slope of 0, which means I have either the horizontal or the vertical line. Maybe you can't remember which one it is, but we can totally figure it out from this. So my y-intercept is going to be 0, 3, and then my slope is equal to 0. So I'm going to go up 1, 2, 3, and now to get to the slope, I go up 0, right? And I can go over 1, right? So if I just go up 0 and over 1, it would look like this. So this is actually my terribly drawn horizontal line, trying to make that as straight as possible. Okay. So now moving on to B here. So in this case, my slope is -2, and my y-intercept is 0, 1.5. So this is a little bit trickier to figure out, so you got to be careful with this. So you got to kind of estimate where the 1.5 is. So I come up here to 1.5, so I'm right here. And then I'm going to go down 1, 2, and over 1. And there you go. Down to always to the right 1. Always, always, always to the right. Okay, so here for C, so now my slope is going to be -2. And once again, I don't have a y-intercept here, so this will just start at 0, 0. So here I am starting at 0, 0, and then I need to go down 1, 2 to the right 1, and there's my line. All right, so now moving on to the next page, and this will actually be the last page that we'll do here. So we should also be able to reverse engineer equations for graphs now just by looking at the graph. So before we were figuring out the slopes, but actually from this I have enough information now to figure out the slope-intercept form of a line. So first and foremost, looking at this graph, where is the y-intercept? The y-intercept happens right here, right? So my b is equal to -3. So now I just got to figure out what is my slope. And notice I did not make this like easy for you to count from one point to the next. So just looking at this graph, what's like the other point on this graph you could most easily read? Well, I would probably say like this point here, I can definitely tell what this is. So this is the point -3, this is like the point -1, 1. So I can totally count from here to here. So I can draw this line going from here and then all the way over. So this is what I can do. So in this case, this is going to go up 2, and then this is going to be right 1, so I can use that information to figure out what my slope is. So my slope is just 2. So now if I'm using this y equals mx plus b form, I just fill in what I just figured out. So this would be 2x minus 3. So that would be the slope-intercept form of this line, so we can figure out the actual equation. Okay, so now I've got b here for you, so why don't you pause the video, give this one a try, hit play when you're ready. Okay, so there's my y-intercept. So my y-intercept is 1, so that's going to be my b, and now I've got to figure out what my slope is. So this looks like to me the easiest other point that I can find. So if I count from here all the way over, so let's see, this is down 1, and then to the right 1, 2, 3. So this is right 3. So if I figure that out, this is -1 over 3. So now if I plug that into my y equals mx plus b form, I'm going to get -1/3 x plus 1. Now the next page is even more graphs, but you're going to get a lot of practice of that on your homework. So I think this is probably actually a pretty good place to end off, so that covers all of 4.2. Thanks for watching.